Hello, learners. Hope you are keeping well. Today, we're actually looking at again grade 11 geomorphology with special emphasis on slope retreat. All right, I know there'll be various things we'll be discussing. The slope development, various things. But if you look at the revised curriculum, it mentions slope retreat. So I'll be talking about a few issues around it in order to get an understanding of slope retreat. Otherwise, it's just hanging, as I always say. Okay, so let's go on and let's look at the first aspect, a little introduction into slope development. All right, some points that we do need to note, like a major part of the earth is covered by slopes. Right, you will get flat areas, but in between those flat areas, you get slopes. Even in dry areas like the Karoo, you will find there's little features which has slopes, and the rest of it is flat. Okay, so we're getting slopes, and obviously it brings out the relevance of studying slopes because it's a major part of our earth that is covered by slopes. Another thing is that slopes differ from one another or from one another. All right. They have different gradients. They can be steep, gentle. All right. They have shapes. Some of them, if you when you did the slope elements, they have a convex slope, a cliff, and some slopes, some just have a gentle sloping. So the shapes change. All right. We just have a gentle sloping land with no cliff. Some of them may have cliffs and some of them may be more convex and then has a constant angle. Some may be convex, steep, gentle. So even the shapes of it change and the size of slopes. We have slopes that are huge, that are found on the side of mountain ranges, etc. And there are slopes that are smaller that even I can walk up. All right, that's meant for me, the old people. Okay, so we have various types of slopes. Now, one other thing that we know that slopes change over time. All right, they change, the shape changes. Sometimes it gets more gentle, sometimes it recedes, it moves backwards. All right, there's various things happen over time. Now, please, learners, this is geomorphological time. And some people like to say geological time. So don't go sit outside your house and look at the slope and say, tonight, I'll watch it, it'll change. We're talking sometime millions of years. Geomorphological time, eh? Don't forget that. So don't sit the whole night. You may see nothing. Maybe lucky a shooting star. Okay, there is a relationship between rock strength and weathering. All right. Now, what does that mean? Greater rock strength, more resistant rock, slower weathering. So it will affect the processes of the change of the slopes. All right. So there's a relationship between those two and weathering to climate. Also, when we look at how the slopes retreat over distances could be large and time spans. Okay. So as we said, rock strength, slower weathering. It'll take longer to weather. All right. The slopes may not move backwards very quickly because of the resistant rock. All right. Then we look at another thing. If it's humid areas, there will be more deposition of material on the slopes. All right. Okay, more depositing of material on the slopes because of the weathering of the material coming down, and there'll be more deposition. Remember, it's humid, water, etc. In the dry areas, there is more transportation of eroded material. Some examples, because drier, you understand, less weathering in terms of water, etc., more material transported. Okay, now when we look at this, we need to tell ourselves also, I know there'll be more facts come into this, but I felt this gave me a good introduction into the processes of soil or slope development. Now, I've learned something, learners, and I found this to be a huge success when doing geography. All right, I'm specific to geography. Before we do anything, suddenly I'll be talking about, I say, whoa. And as I say, there's Scree, there's denudation happening on the slope. You understand? Therefore, this and this will result. And you say, okay, uh, yes, but do you know what's these concepts? All right. You need to know. And even if you get a resource that tells you that denudation, or we may find backwasting happening and the slopes change, please, learners, go back and look at what these concepts mean, because you may not understand the process being explained to you. So important in understanding the concepts. So I know I spent a little time on that. So in order to fully understand the theories of slope development, which we will do later, all right, we need to have an understanding of processes and concepts that will be explained in the next few slides. You will see, learners, how important that would be. Okay, that we need to understand this first before we discuss things like Payne's theory and whatever. Okay, so let's get going. And it's going to assist you with various other things. Okay, I always find when I'm in class, I do the same. You find out what the concept is first and then apply it. But don't just go and do an explanation without understanding the concepts. I've said enough of that. All right, now let's look at this. We'll be using the word Pediplain. All right, it's a large plain or generally flat area formed in a desert by the joining of pediments. Now, you've learned when you did slope elements, pediments is the gentle slope. And you've also picked up as it recedes, it increases in size. Now, let's look at it this side. That's also a pediment. You understand? And as it recedes, it increases in size. This area gets flatter and they join, forming a pediplain. All right. So we know what's a pediplain, a large flat area. We're just going to fool around with concepts first so that we know we're safe. Okay, let's go on. Now, a peneplain. Can you see the difference? All right, this is a low relief found in a very low area formed by protracted, or that means continuous erosion. So what's happening? There we may have an area, but more and more erosion is happening and continuous erosion of those areas. And what's happening now? This low-lying area is getting bigger until it becomes a low relief and continuous flat area as shown in this. Can you see it? Large area, a penny plain. Okay, let's go on. We look at the word backwasting or backwearing. Guys, this backwasting doesn't mean you have a back problem like me. All right, you are young. Backwasting, look at it, is the recession of slopes with little or no loss of steepness. Just the landform becomes narrower. Recession, moving backwards. All right, can you see? Recession, going. All right, now look at this. Let's try and make sense of these words here. Look at this. There's the slope here. All right, now recession. There's it here. It's moved here. Can you see? The angle has not changed. It's still the same steepness, but it has moved, or recession has happened. It's moved backwards. That is why it's back wasting. It's cut out this piece. All right. And if this was a full feature, Isn't it getting narrower? It was from there to there. Now we've got the feature from there to there. So it's getting narrower. Obviously, it's going to happen. Backwasting is going to happen here, and it's going to get narrower. But the steepness remains. That's backwasting or backwearing. So you know. All right, let's go on. Downwasting. Okay, that's back. Can you see? Now we talk about down. Okay, down. Look at my hand, down. So what happens here? It's the wearing down of the land mass or landscape by weathering and erosion. What does it do? It's the height is being lowered. That is why we got down now. Can you see it? Look at this. You have this area being eroded, and you have the area, we have vertical, lateral, all right, erosion happening. And what's happening now? Look at the surface here. As more and more erosion is happening to this, the height is being lowered. Can you see it? It's going down and down and down. All right, because of the wearing away of the last mass by weathering and erosion. All right, and it makes it lower. So that's down wasting. Use the name also. All right, let's go on. Parallel retreat of slopes. All right, again is the recession of slopes without change to the topography. Example, height. That's why it says parallel. Can you see it? The same shape. And as it recedes, it goes backwards. Can you see? The same shape, not much change to its topography. Can you see? The height and the shape, and it continues in the same way. All right, can you see it? It's just this pediment gets longer. But can you see the shape of these ones? It stays the same. Okay, in terms of height and steepness and whatever. That is your parallel retreat. Because you can say this line is parallel to that line, is parallel to that line, is parallel to that line. All right, parallel retreat because it's going backwards. All right, can you see here? Parallel retreat. It's going down, and look at the shape here, and look at the shape there, and you notice it's making it narrower as it flows, but the steepness is more or less the same. Okay, let's go on. Then the word scree is a mass of small loose stones that form a cover form or cover a slope on a mountain. So can you see here? You may have the crest there, you may have the cliff here, and there's your deposition happening. All right, if you did your slope elements, there's your scree slope. All this loose material. I'm going crazy with it. So this is actually scree in this little picture. Can you see it? That has been eroded and is getting deposited there. Talus, an outward sloping accumulated heap of mass of rock fragments lying at the base of a cliff. So at the base of the cliff, you will get, this is actually more scree, but a heap you will get down here. All right. And then debris, an accumulation of relatively large rock fragments, big pieces of rock that could lie in the areas. All right. That is debris. So all this gets deposited on this scree. Remember your known as your scree, your talus, or your debris slope when you did slope elements. Right, that's where it gets deposited. Okay, so that's the different concepts there. Then the concept of denudation. What is this? It is the process that caused the wearing away of the Earth's surface by moving water, ice, wind, waves, leading to a reduction. It can be in the elevation or relief of landscapes. Look at this. This is being weathered. There's some rainfall, possible weathering. You understand? Erosion, weathering, and what's happened to this material. And this is more like a cliff, eh? If you looked at your slope elements, the section you did before this, this is a cliff. So what's happening to this loose material? or this material is getting loose, it's getting worn away, and it's going down. And the chances are that this is being deposited on the Talus slope or Scree slope. So denudation, denudation, I'm forgetting always. Denudation, sorry, my apologies. The other one sounded nice, denudation. Actually then wears away and that gets deposited. Okay, so we're doing all these concepts and you'll watch them now being put into action. So what this actually tells us also that we need to have our knowledge of slope elements that you've done before this lesson in order to understand. And you know your slope elements, crest, cliff, talus, and pediment. Okay, if you remember that. All right, you should actually remember that. All right, so let's look at the theories of slope development. I'm calling it slope development in a nutshell. Okay, there's various ways of looking at it, but I'll call it. Let's look at this in a nutshell. And remember this, I'm going to take the same one and create some questions on it later, just to fool around with now in a nutshell. Not that is not important. Okay, we look at retreat, one of the ways, slope retreat. All right, here the slope moves backwards. Slope elements, crest, cliff talus, maintains its shape and gradient. That is what we talk about, parallel retreat. So when you see this, can you see the shape? And this is parallel to that, and that is parallel to that. Can you see I used the word parallel retreat? And we did parallel retreat earlier. You understand where I looked at that explanation. And just to use one as an example, Ernest, right? I want to go back to that. Can you see? If you don't understand the thing, it's a recession of slopes without change in the topography, height, and the gradient. Can you see it? We've done it here. Now, when you get these things, it says parallel retreat. Can you see it? Without change. And because you know the concept of parallel retreat, you are fine. So it's important to know concepts. All right. There's nothing wrong with your resource books, but they are on the assumption sometimes that you know that, and some books may give you a little description. Important to note. So we talk about slow retreat. There's it receding, all right, but the gradient, etc., are being maintained. This is known as decline. Here, the slopes become gentle and flatter over time. Can you see? 1, 2, 3, 4. They become more gentle. So that is why we use the word decline. Can you see it? We can link up words with that. All right, slope decline. And then slope replacement. Look at the word here. It makes sense, learners. All right, where a steep slope is replaced by a gentle slope. So this is the general idea now. Of course, we'll go into more detail about each one, but you need to know that so you can differentiate with the main ideas, okay? So let's look at the theories now, all right? And the first one we have is our slope decline. We said it when it gets reduced in height, okay? So let's look at it, okay? Now, this was Davis's theory of slope decline. This is what it's based on. He used a lot of humid areas, okay, humid temperate regions, because you found that there's water erosion, etc., happening. Obviously, we all picked up, and it works everywhere. Slopes evolve through time, through geomorphological time. Okay, geomorphological time. Just remember that, geomorphological time. All right. Now, it takes millions of years or whatever. Now, let us look at this. All right. I want to cover this word. I try to cover it, but it's trying to sneak in here. So let's just cover that out. I don't want to look at that word. It's a grade 12 concept. We learn it in grade 12. Okay. So I will make sure the slides are correct. All right. My apologies. So it evolves through time. And he mentioned it, the slopes go through 3 stages: the youth, the mature, and the old stage. So in the youth stage, it has V-shaped valleys due to vertical erosion. So remember, the surface is like that. Okay, now we're getting vertical erosion. And when you start digging vertically, you'll find that it'll have narrower V-shaped valleys. Okay, as you see it there. Now, as it accumulates material that's being transported and it gets a little into the next stage, which is your mature stage, the valley becomes more U-shaped because now we're not only getting vertical, we're getting lateral. All the material being carried is now eroding in a lateral fashion, horizontal, okay, eroding into the landscape. So what's happening now? It's more U-shaped. Can you see? U-shaped valley. All right, U-shaped valley. And then eventually, as more lateral erosion, etc., is happening, and there's a possibility, of course, of deposition when it's in the old stage and lower down, you will find that it's gentle and flat, gently sloping terrain called peneplains. Can you see now the concept of peneplains? You need to know it. All right, it's gently sloping low-lying terrains. All right, which is known as peneplains. All right, so it's going down. All right, and you notice as from there to here, Davis in his theory has mentioned. Can you see it's going down? So therefore, this process is also known as down wasting. Can you see that, learners? We're using the concepts now. That's in a nutshell Davis's theory of slope decline. Main things, as I showed you, the main points is that the area goes down, it declines, it comes down. Okay, due to vertical, lateral erosion, etc. Okay, let's look at the next one. Slope replacement. Now let's look at this. Stage 1 to 3. It's based on the theory by Penck, another brilliant man. And again, slopes evolve through time, millions of years. All right. Here it says the tectonic processes cause uplift. Remember, tectonic processes like faulting and folding, all lift up, whatever the stuff. All right. You, for instance, you have a place and suddenly you have folding and strata gets uplifted. Okay. He based it that a uniform rock structure, uniform rock slope equal to weathering results. This is his theory, that this whole thing is uniform, it's equal to weathering. All right. Then he says denudation occurs. That means there's wearing away of the surface. Can you see? I want to go back to denudation. I do apologize just to show you the importance. Can you see? Denudation happening. Learners, so you see, you need to know the concept. Now it makes more sense. So denudation happens, and we go back to our slide. All right, back to our slide. All right, there's it. Denudation happens. So those wearing away of the rock, and therefore scree, debris, or talus accumulates at the base of the cliff. Can you see the free face? It accumulates there. Now, what is scree? Those material that is deposited. Remember, I showed you the pictures. Scree gets deposited. And then you got talus, which is larger boulders, debris, all those things get deposited. Of course, there's erosion here, it gets deposited here. All right. The gentler slope replaces the steeper slope. Can you see now what has happened here? Deposition has happened. Deposition has happened. The height of things has not changed. But as more and more deposition is happening, can you see it? All right, you see less of the cliff. But what happens to the slope because of the deposition? Steep, gentler, and more gentle as material gets deposited. So denudation occurs, and of course, all the scree and debris gets deposited at the edge of the cliff. What happens to that area? The cliff now gets covered and covered and covered. Can you see it? From there to there to there. And therefore, the slope becomes more gentle as it's getting there. So the height of the slope remains the same. Can you see the height? Height remains the same. The center of the slope takes a more concave shape. You look at here, can you see the concave shape of that? All right, that's slope replacement. Oof, I'm always going off. Slope replacement. I do apologize. Fingers are getting a bit old today, so my apologies for that. All right, let's look at the last one. Scarp retreat or slope retreat. All right, or parallel retreat. Can you see all these concepts are coming up? Okay, now we can see we already know what's scarp retreat, steep slope retreating, or slope retreat. You understand? We know all these things are happening. So I can add the word here, slope. Okay, whoa, my writing is getting better, and I want to put in a P, and I want to put in an E. So I can put in a slope retreat also. Now, if you know Lester King, a famous South African geomorphologist, etc., I in fact had an opportunity to meet him when I was fairly young and a student. Brilliant man, known worldwide also, but I wanted to point out he is South African. All right. Theory of parallel slope retreat. All right, he brought this. He looks at slopes developed in those semi-arid regions, example, your Karoo landscape. All right, and he looks at how they retreated. Okay, so he said uplifted landscapes, again, there's uplifted, are eroded by rivers. Okay, and then we find that there's a stage reached where there's an equilibrium between the rate of weathering and deposition of material. Now we find that the crest, scarp, and talus will maintain its gradient as it erodes backwards due to this. All right, so we have parallel or scarp retreat. Look at it here. Can you see it? It's moving. Again, it's going backwards, but can you see the slope? It's the same. Look at this. It's the same. It's the same. It's the same. Okay, so we have this parallel or scarp retreat happening. Okay, or slope retreat. All right. And then due to backwards erosion, the pediment increases in size. Can you see this thing is moving backwards? Now look at this original size of the pediment. Now look at it now. It's increased in size and it's increased in size. All right. Obviously, there's going to be other features that's going to experience the same thing, where it's going to recede. All right. And as we did the Pediplain, it's increasing. There's an increased area of the flat area down here. So these pediments join other pediments and they form a Pediplain. So the increase in size here. Can you see how interesting it is, learners, that we use those concepts and we explain this? All right. Now, let's look at this. I have done this. I've taken that little sketch that we took at the beginning and we just briefly discussed all the three and compared them. I've got that same slide just below this. All right. It's exactly the same slide. All right. Can you see it here? Now, I just taken out information. All right. So I said, now, A, B, C. Match sketches A, B, C with the following concepts. A, you notice what's happening. It's retreating. Can you see the words now? All right. Then this slope retreat would be A. Now, let's look at this one. B, what's happening? The slope is coming down. It's getting more gentle. It's coming down. You understand? It's declining. Can you see it beside the gentle? But it was there. It's coming down. All right. So this now would be decline. All right. So that would be A, slope retreat. And then decline would be B. And what happens here? That steep slope has been replaced by a gentle slope. So obviously this would be slope replacement. All right, can you see how we can work it out? Same diagram. Now, give reasons for your answer to question 1.1. Now, learners, all I did was take that information, turn it into questions, and if you just apply yourself, that is why it's so important to apply yourself. It's not new information. What am I doing? I'm giving reasons for why that or this one would be slope retreat, why this one will be slope replacement, and why this one will be slope, uh, uh, sorry, this one will be slope decline, my apologies, and this one would be slope replacement. I want to give reasons why. It's not new information. If I go back to my slide, I know retreat when it moves backwards. You understand? And the slopes, can you see they're moving backwards? Or they move backwards, they retreat, but they maintain their shape and angle. So that is why it's retreating. Why would this one be replacement? Because you find a steep slope is being replaced by a gentle slope. Why is this known as decline? The slopes become gentle and flatter over time. That's your differences, learners, straight from the articles that you studied. But questions get just turned around. So in this question, if you look at it, learners, all we have to do is give descriptions that show the differences of how you identified each one. Now look at this. Explain how denudation and Scree, I hope I now see I got it right, not what I said, but it's denudation and Scree assist slope development of C. Okay, now how does that now? All it's asking you is go back to that theory. All right, let's look at that note, and I want to show you that all is in your notes. You just have to apply it to the question. All right, look at this. Can you see denudation occurs where the material is worn away? Okay, Scree is where it gets deposited here. So what happens? It gets eroded, it gets deposited, so therefore it makes it the slope more gentle. Can you see it? Straight from the nose. But you're not just going to get straight. It says, this is Penck. Tell us about Penck's theory and finish. You'll have to take the information and tweak it a bit, okay, in order to make it apply to the question. Can you see? So all your work is done. Learners, you must apply. Okay, so with that one, it speaks about denudation, all right, where the material is worn away, all right, changing the relief or whatever. You understand, in this case, not so much, all right, material is worn away, and then Scree is where it accumulates just near the cliff and accumulates on the Scree slope, turning it from steep to more gentle. All right, that's how we get this replacement from steep slope to gentle slope. Okay, so I have a little idea, but I'm sure your teachers will have better questions than I have because they are more brilliant. You understand? But anyway, I hope you enjoyed this lesson. All the best, learners, and goodbye.